Hello everyone, this is Swaminathan, Assistant Professor, Department of Mathematics, SNS College of Technology, Coimbatore. Today we are going to start a session that is the topic of solution of first order differential equation in ordinary differential equation. Here we are going to discuss about the solution of differential equation, basic concepts, methods and applications. Let us see the one by one concepts. First, the definition and basic concepts. What is differential equation? A differential equation is a rate of change describing in dynamic systems. So, important of differential equation is the model real world process helping predict behaviors in science and engineering. Here, let us see the real world example of differential equations. Now, the population growth models. The population growth and decay. mm, Imagine you're studying how population grow, like people in a city, bacteria in a lab, or even followers on social media. So what happens? The more people there are, the faster it grows. That idea where change that depends on how much already there. So is modeled using first order differential equation. Same thing with decay. Radioactive substance, medicine leaving the body, the battery draining. So anytime something is increase or decrease based on its current amount, this math is behind it. The next cooling physics application, that is cooling and heating. Now think about a hot cup of coffee. When you leave it on table, when so it cool down fast at first, then slowly reaches room temperature. Why? Because the temperature difference between the coffee and the surrounding keep sources. Engineering use this concept in heat transfer, thermal system, even forensic science. So, yeah, this math can actually help estimate things like time of death in investigation. Next, chemical reaction and electrical circuit. If from the electrical and electronic engineering, this is where things get real. In a circuit, capacitors change charge and discharge. Voltage changes over time. So these changes don't happen instantly, they follow pattern. That pattern is described using first order differential equation. This is used in circuit design, power system and signal processing. So basically a lot of modern electronics depends on this types. Next, the mixing problems. Now imagine the tank filled with water and salt. So fresh solution flow in, mixer flow out. Over time the concentration changes. This kind of situation appears in chemical engineering and environmental system and industrial process. So the big idea here's most important takeaway: the first order differential equation are used what whenever something is changing over time, and the change depends on the current state. So classification of differential equation. Ordinary versus partial. So there are two types of differential equation. One is the ordinary differential equation, another one is partial differential equation. Then second one is linear versus non-linear. It means the second thing is linear differential equation and or non-linear differential equation. Third thing is order of the equation, and fourth is homogeneous or non-homogeneous equation. Then fifth one, the stage is explicit versus implicit. Let us see the classification in next video. Thank you.